Morning, everyone. Thanks for coming. Last day, early morning. Good show last night. My name is Jason Brown. I work in product marketing for Dell EMC ScaleIO. I'm going to talk to you today about ScaleIO and VMware. So, anyone heard of ScaleIO before? All right. Well, everyone. Oh, so I don't even know why I'm here. So, so ScaleIO acquisition by Dell EMC back in July 2013. It's software-defined storage. Who's heard of software-defined storage? Of course. So I want to talk today about why you would use ScaleIO for VMware. You know, there's a lot of confusion out there a little bit and questions about when do you use ScaleIO, when do you use vSAN, right? So if you're familiar with those two technologies, they're both very, very similar from the outside. But if you get to know them, there's a big differences between the two. So you try and help you guys understand when to use each and why ScaleIO for VMware is actually a good thing. So if you have any questions, we'll keep them to the end just so we keep the presentation flowing. Disclaimer, blah, blah. So some industry trends, first and foremost. So obviously, if you've heard of software-defined storage, you know that it's growing pretty rapidly, right? There's a lot of talk out there today about SDS, HCI, and it's coming at the expense of traditional architectures, these arrays that we have been buying for the past 20, 30 years. And this is a study from Wikibon who said that within the next 10 years or so, the SDS market is going to grow at a 22% growth rate to over a $50 billion market by 2026. And that's not that far away. You think about it, it's less than 10 years away. And it's going to happen in two different arenas. So obviously the public cloud is growing pretty rapidly. We're very familiar with Amazon and Google and the things we're doing here, right, with VMware. At the top part, that's going to take over some of the market share. What else is going to happen in that hyperscale market is the companies like Facebook or Twitter, they'll build their own data centers with their own commodity hardware and software and start to move away from anything that they've been doing in the traditional manner. On the bottom side, enterprise server SAN and HCI. That's our ScaleIO. That's our vSAN. So these technologies are going to take market share as well at the expense of these traditional architectures as well. But it's very, very important to understand there are three types of SDS in the market from an architecture perspective, and they're not all the same. So first and foremost, there's something we call retrofit SDS, which essentially is just a packaging exercise. In truth, it's really a SAN, so this a company has decided to repackage their SAN in a software-defined manner by meaning that, yes, we can run on x86 hardware with VMs, but it really don't get the benefits of SDS and HCI. There's not much scalability, not much flexibility. You're not bringing the applications into a single architecture like you would. And you can see here that still those applications live outside. So really, it's not really the most optimal piece of SDS we feel at Dell Technologies. The next is something called vertically integrated. This is HCI, basically. So basically what a company decides is that we want to simplify the stack for our VMware administrators, for our VM administrators. So we've decided to work on a system that essentially takes the compute, the storage, the application, all the management together into a single stack vertically and make it as simple as possible to manage. So you are somewhat limited with a single hypervisor or OS, but you can still do work, you can still optimize your TCO and get a lot of benefits with multiple workloads as well. And that's something like vSAN, for example. Now the third type is what we call general purpose or horizontal, or enterprise SDS. The purpose here is to actually simplify the data center by consolidating resources and sharing resources across systems. So as opposed to going up the stack in a vertical model, you're going across the stack here. And the goal here really is flexibility. So and in this case, typically it's managed by the storage or server admin. It can be managed by the VM admin, but that's not the total focus here, because we're really focused on the storage. But the goal is flexibility and optimizing those resources across all those disparate systems to give you a comprehensive software-defined storage platform to do not only multiple workloads, but also multiple OSs and hypervisors. So not only can I run ESX, I could run Hyper-V, I could run KVM, I could run Linux, I could run Docker, right? So you've got a lot more flexibility in this use case. So the goal is here, again, vertically integrated, like vSAN, simplicity up the stack. Something like ScaleIO, more horizontal, goes across the data center, and the goal there is more flexibility. So very important to understand that. And that helps you decide which product I would use in my data center. vSAN, ScaleIO, there it is. So what is ScaleIO? So most of you have heard of ScaleIO. So essentially what it is enterprise class data center grade software defined storage. We've taken the tenets of what VMware did for compute way back in 2001 and applied that to storage. Abstract, pool, and automate. So we want to abstract those local resources from those x86 servers in our data center. We want to pool it all together so that an application isn't limited to having only the local resources that it would have on a single server. We want to open up all those resources that we just abstracted to the entire application. And then on the back end, tons of automation, right? Tons of automation in how you manage it, tons of automation in how we move storage around, tons of that automation in how you add, remove, and reallocate storage on the fly, tons of automation in that we actually eliminate data migrations and tech refresh. So and the culmination of all this automation is essentially a software-defined storage platform that can replace your SANs. It can replace your arrays. Because with that horizontal architecture that I just mentioned, the entire goal is to give you an enterprise-class data center-grade platform for Tier 1 applications, Tier 2 applications, and even next-generation applications like Docker, like Mesos, like Kubernetes, like Splunk. So we're providing a high-performance platform with extreme resiliency with ScaleIO. And actually, there are customers out there today, so customers that have actually replaced their entire SAN array environment with ScaleIO. So let's look at it kind of in a pictorial way, a representative way. So if you think about a server farm today, those servers on their own are somewhat impressive. Maybe they're all flash servers, maybe they're spinning disks, maybe there's NVMe in there. With ScaleIO, we don't really care. But what happens in a VMware environment, right? You've got ESX clusters, right? An ESX cluster can just scale to 64 nodes, but you can't really scale beyond that. So you really usually have clusters of ESX in your environment. You can manage them from a single window, of course. But from a physical perspective and a logical perspective, you've got this kind of separation. So wouldn't it be great if, even though we have this logical separation in VMware clusters in our data center, if we could still abstract that local storage out? Like I said, whether it's NVMe, PCIe, SSD, or even spinning disk, we take it out of those servers in a virtual manner. We abstract it. And then we pool it all together. So now, for example, the VMware cluster before that was really only 4 servers with 250 cows per server. Now, that server actually has access to the whole entire pool. So by an order of magnitude, you've already increased the performance capabilities, the performance availability for the applications, for the VMs, whatever's running on those servers that was running there before. And then we add applications to it. And when we add those applications to the environment, whether they were there before or not, ScaleIO is smart enough to only really give the applications what they need. So you're not wasting any resources here. There's total optimization in the back end because of this automation that happens within the ScaleIO system, so that there's no under-provisioning, there's no over-provisioning. We have this big pool of storage available, storage plus storage performance available to our applications, and then through ScaleIO, we actually automatically provide the resources they need, whether it's 10 terabytes with 400K IOPS or something like Oracle, or whether it's something like a container platform where you need 5 terabytes and 180,000 IOPS. So the ability to automate is really crucial here because, yes, it's great to abstract it and give you this big pool, but if you're not smart in the back end to really ensure that the system is easy to manage and easy to use, you kind of lose a lot of the benefits of any kind of SDS platform. And then never mind the resiliency, right? So I mentioned the resiliency, right? There are customers today reaching 6 nines availability with a ScaleIO platform in VMware environments. So if you really need that, enterprise class storage, but you want it in a software-defined model, ScaleIO is a very valuable platform for you. So how do we do it? So there's really 3 components of ScaleIO that you need to know. So as I said before, ScaleIO is installed on an OS or hypervisor. So there are really what you're installing are 3 lightweight applications of about 500 megs each to create your storage system. It's a client-server model. First piece is the client, the SDC, the ScaleIO Data Client. This is your block device driver. This piece of software is installed on any server where you have an application or VMs that you want to access the ScaleIO storage component, basically. So you've got a server running Oracle or whatever it may be. You want to install the SDC on it because that's going to be the connection point for your applications where you present a volume to that application through the client. Second piece, obviously, as it's a client-server model, is the server piece, the SDS, the ScaleIO Data Server. So the SDS is important because you want to install that on any server that you want to take storage resources from. So any server, whatever it may be, whether it's one that's a spinning disk in it, whether it has NVMe in it, whether it has mixed media inside of it, if you want to take some of the storage from that server and put it into that big pool, the SDS needs to be installed on that server or that node, whatever your consumption choice may be. Because the SDC and the SDS are going to communicate together over TCP/IP. They have a proprietary protocol where they talk together over TCP/IP. So you're actually eliminating the need for fiber channel or iSCSI in your data center as well because of this client-server model and because of our proprietary protocols that talk over Ethernet or InfiniBand over Ethernet. Last piece is called the MDM, the metadata manager. This is our config manager. This is kind of the brains behind some of that automation that I mentioned before, the rebuilds, the rebalances, the allocation. So this guy's important, but we don't really talk about it too much from an I/O perspective because it is outside the data path. It really is just a component that is keeping tabs on the system. It keeps the layout of the entire system, the mapping. And it's there to essentially say, okay, if a failure happens or if I add more servers or more nodes to my environment, the MDM kicks off and says, oh, okay, I've got something happening here. Let's see what it is, and let's start doing that automation piece that I mentioned before. So let's look at ScaleIO in an ESX environment. Anyone familiar with this picture today? We've got a bunch of ESX hosts. They're connected through fiber channel to a traditional storage platform, whatever it may be, whether it's Dell EMC or not. And over the years, we've become to learn that it's fairly inefficient to do this, especially in VMware environments, because you probably don't need the capacity and the performance that you may need from these arrays because they, are extremely expensive. They're usually underutilized or overutilized, and they can't necessarily scale the way you want them to in a traditional ESX or even non-ESX environment. So as I said before, ScaleIO client-server model. The SDC runs on a server where there's an application or a set of VMs that you want to use the storage for the ScaleIO system in the back end, and the SDS is the storage component. So very, very critical here to understand that the SDC, that client, that block device driver that the applications talk to, that you present volumes through or LUNs through VMFS, RDM, or even now direct DPIO, direct path IO, that's actually installed into the hypervisor kernel. There are only two platforms in the world, two products in the world that are installed into the hypervisor kernel, ScaleIO and vSAN. So because of our relationship with Dell Technologies, we have a very, very tight integration with them to be able to actually incorporate our client piece of the puzzle into the kernel itself. So it's not in ELA. It is actually a component that is installed into that kernel. So it's very important to understand that because it is a big differentiator from any of the other SDS platforms out there today except for vSAN. And the SDS, while not in the hypervisor kernel itself, is installed as its own SVM called the ScaleIO virtual machine. Excuse me. As I said before, it's a daemon, it's a service, it's installed as a VM, and that's the storage component. And these guys will talk to each other over your NICs, because as I said, it's Ethernet, it's TCP/IP based. So you're talking over your NICs, whether it's InfiniBand or Ethernet, whether it's 1 gig, 10 gig, 25 gig, 100 gig, really doesn't matter to us. We don't really care in the back end. But the key thing to understand is that they will talk together whether they are living on the same system or not. And this picture is a little wonky because there's no real sense of locality with ScaleIO. Even though I've installed the two components on the same platform here, the storage is not utilized on the primary server, in a localized way. The system with that automation looks to actually see, okay, where's the best place to put my data, right? It's a 2-copy mesh mirror, which we'll talk about, but this kind of just shows you when you're installing the components where they may be. And the space that the SDS takes up is actually up to you. Do you want to allocate a volume? Do you want to allocate a disk? Do you want to allocate all the disks in the server? That's really up to you. So you've got a lot of flexibility because, once again, this horizontally based architecture gives you flexibility in how much storage you want to take from those servers or nodes, whatever you want to call them. So you actually have a lot of flexibility to decide, do I want to just use my NVMe drives for the ScaleIO cluster? Do I want to use all of the drives for my ScaleIO cluster? You've got a lot of choice there. So let's look at what it kind of looks like here. This is just a representative example here where you've got SDCs installed on some ESX nodes, and then you've got SDSs installed on other ones. So it's a mesh layout. And what does that mean? Well, a single SDC will talk to multiple SDSs. Because if you think about that, if you have one application sitting on one of those ESX servers, how is it going to talk to the storage, right? It's actually going to talk to multiple nodes to be able to provide not only the capacity, but also the performance that you may need for whatever kind of I/O you're doing. So a single SDC talks to multiple SDSs. And if you look at a ScaleIO cluster, right, when you build it all out, you're going to have this massive cross-communication occurring within the system behind the scenes to enable that automation I mentioned before, to enable that big pool of storage and that abstraction that I talked about as well. So it's a massively parallel approach. So all these things are happening in parallel, and that's why, when I mentioned before that you can run multiple applications on this, multiple workloads, it's because of this model here, because of this mesh mirrored layout, where even you can have multiple applications in your system, but they're only talking to their specific SDSs. In this use case, there's a lot of cross-pollination, but you actually have the ability to segregate that as well and segment it. So you can have a sense of multi-tenancy within your platform so that one SDC could only talk to a specific set of SDSs, and you get the kind of security you would need in an enterprise data center. There's no hotspots as well, and what's really critical and crucial about this is that whenever there's a rebuild, a disk goes down or a node goes down, all those SDSs that are part of that one SDC link will actually talk together to rebuild that data as fast as possible. So we had a customer testimonial where they had a 2 terabyte SSD that was failed. It was 80% full. It actually rebuilt in 90 seconds. So the rebuilds occur very, 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 very fast because of this model here where all those SDSs will come together and say, okay, I've got to rebuild that data as fast as possible because I've seen a failure and I want to get that 6 nines availability that I mentioned before. So flexibility also very important in terms of how you deploy it. So if you're familiar with HCI, right, you can only really deploy one way. You've got compute and storage together on the same server. Because your goal is to maximize the efficiency of the platform, is to reduce the bottlenecks, and to give you a single platform for HCI. With ScaleIO, you actually have some choice again, more flexibility in how you deploy it. Because if you think about SDS and even HCI, it's transformational in 2 ways. We're talking about IT transformation here all week at VMworld 2017. So you're transforming the architecture for sure. If you're moving from an enterprise storage array to software-defined storage running on x86 servers, Dell-powered servers, for example, you're transforming the architecture out of the gate, right? Pretty straightforward. But with things like HCI and even SDS, you're also transforming your IT operating model. And that's important to understand. And also very scary for a lot of CEOs, CFOs, folks I talk to, because even though they want to get onto this train of SDS and HCI, they're very, very concerned about what happens in the back end. What happens to my people? And the people are concerned as well, right? If you all of a sudden were a storage admin living in your own little world working on your box, then someone comes into you and says, hey, we've got an appliance now, and you're going to work on that with the server guy and the VM guy. There's going to be some confusion and some of this. So the magic of ScaleIO is that you transform the architecture out of the gate, but the IT operating environment can transform over time. Because we enable you to deploy it in a few different ways. Because we've got these SDC and SDS, 2 different components that are lightweight and installed on your servers, if you are smart enough to understand where you want to install them, well, you can actually preserve your IT operating model. So if you look at the far left here, this traditional 2-layer operating model is what you would find in a traditional enterprise data center today. Network admins, server admins, storage admins, all living together and not talking to each other, right? ScaleIO can actually preserve that IT operating model with our software, because if you just install the SDC, that data client, on the application servers, the VM servers, but not the SDS, you've actually preserved those servers as your app servers, your VM servers, whatever they may be. You're not taking any of the storage from those servers into that big pool of storage. They're just sitting there being your compute nodes, essentially. And then on the bottom part, install your SDS, your ScaleIO data server, not software-defined storage. You install that onto your other servers, the ones that you actually want to allocate storage from, that you want to take storage from. So now you have this 2-layer. You've got your compute nodes with the SDC on those, doing their thing, running their apps, running your VMs, wherever it may be. Then you've got the SDS nodes doing their thing, just providing storage, essentially. So you've transformed the architecture of your data center, because you're now running on x86 servers with Ethernet for your storage array, essentially, right? but you preserved your IT operating model. Your server guys still do their thing, your storage guys do their thing, and the network guys are doing their thing as well. And in an ESX environment, it's kind of hard to see the text here, but what's unique is that would you, if you were operating in this model, would you use ESX for your storage nodes? Probably not, because why would you waste the license on your ESX? Instead, you'd use bare metal. Why don't you just use KVM or Zen or some form of Linux, Ubuntu, for example, for your storage nodes? So even though you've got ESX hosts doing their thing up there with their VMs or apps, the storage component can actually be bare metal Linux, whatever it may be. So you're able to make your storage more efficient because you're not wasting your money on ESX licenses for your storage nodes, because that would be kind of silly if you think about it. Now, there are other customers that come to us and say, no, SDS is the way, HCI is the way, I want to transform my architecture, I want to transform my IT operating model as well. That's really what hyperconvergence is all about, right? And that's this middle one here, this modern or one layer, co-resident, HCI, whatever you want to call it. There's tons of buzzwords for it. I'm a marketing guy, so we find them all. But in this case, you're actually using the same nodes, the same ESX hosts for not only your compute, but also your storage. And this is the way to maximize your total cost of ownership, minimize your total cost of ownership, maximize your efficiency, to ensure that you've got really the total next generation platform. But this is where you also transform your IT operating model. So now your storage admin, your network admin, your server admin, they are working together on the system. They can become more generalists. So for customers that want to transform not only the architecture, but also the IT operating environment, this middle one here is really where they would go, and that's the kind of the tenets of HCI. Now, because we're ScaleIO, we give you the best of both worlds. This one on the right, a mixed configuration. So maybe you're an enterprise today and you like the vision, you like the thoughts of HCI and being able to transform the data center, but you're not ready to go there yet. So with ScaleIO, you actually can run in a mixed environment where some workloads could be that traditional model, that two-layer, and some workloads could be that next generation modern workload as well. So you've got a lot of flexibility in how you deploy ScaleIO. And what's unique is that ScaleIO really is the only platform out there today, and please correct me if I'm wrong later, if there's something else out there, that can give you these deployment options. And we're at VMworld, we're at VMware, we love our VMware friends, and we've done a lot of work to ensure that the things you use as a VMware admin, you can use with ScaleIO. So we work with 5.5, 6.0, 6.5. We have a very tight integration with ESX, where you can actually use vSphere to deploy, configure, and manage ScaleIO. You can use the various replication tools out there, the vRealize suite, and then those features that you love as a VMware admin, vMotion, Storage vMotion, DRS, those are all incorporated with ScaleIO as well. And there's more to come, a lot of innovation happening within our company. ScaleIO deployed on vSphere with DirectPath.io is coming in our next patch, our next service pack, which is coming out this month. And then towards the end of the year, early next year, with our next release, our big major release, we're actually going to vVol support as well, where you can actually have 70,000 vVols in your ScaleIO cluster. That's actually a lot. If you don't know anything about vVols, 70,000 is a lot. But it really goes beyond that as well. So as I said, ScaleIO will actually scale and start at 3 nodes and scale to over 1,000 nodes. So you can actually build a very, very, very large ScaleIO cluster, and it doesn't need to be just for VMware. If you have VMware workloads, perfect. But if you have other workloads as well that are running on Linux, Windows, any other type of hypervisor out there, any container platform, ScaleIO will support that as well. And it can run with any type of media. So once again, flexibility, that horizontal architecture we talked about at the beginning, that's what ScaleIO is, because we want to ensure that whatever workloads you need to run, whether it's a tier 1 application or a tier 3 application, whether it's a traditional application or a next generation application, ScaleIO will support that. So it can provide the IOPS, it can provide the performance, it can provide the scale that you need if you wanted to. And in terms of purchasing, well, a few different ways to consume it as well. Are you a do-it-yourselfer? You like to do that build model where you will actually just buy the ScaleIO software, put it on your own servers, whether they're Dell PowerEdge, whether they're HP, whether they're Supermicro, whatever they may be, we can provide that for you. If you're at the other end of the spectrum, where you actually want to just have a turnkey hyperconverged RAS scale platform, well, VxRack Flex is the system for you. Dell EMC will sell you the rack, the hardware, the Dell PowerEdge servers, the ScaleIO software, the networking switches, the networking cables, pretty much soup to nuts, everything. And you would just be able to consume it, put it in the corner, turn it on, and go. And then in the middle, we have the Ready node, which essentially is Dell PowerEdge server, ScaleIO software bundle with some management framework behind it to manage that life cycle, because automation is important, as we said. But then you decide on the OS, you decide on the hypervisor, you decide on the network. So once again, more flexibility for you. So what are people using ScaleIO for? 3 key workloads here, as you can imagine. We're talking about enterprise class storage for the data center grade. So obviously, array consolidation, block storage consolidation is a big feature, a big use case for us. You've got multiple silos of storage in your data center today. It's being very cumbersome to manage. You are having inefficiencies in how you scale. Well, why don't you consolidate those multiple workloads into a single platform with SDS, with ScaleIO? Huge use case for us. Many customers doing that. Second use case is just private cloud, infrastructure as a service, and even public cloud as well. There are many service providers that have bought ScaleIO to build a public cloud offering for SMBs, for individual users. So there are many telecom companies, service providers that have done that. So essentially, you want to build your private cloud, right? You've got multiple business units, you've got multiple customers. You want them all to come together in a single platform, so you have the way to maximize your costs, minimize your costs on the back end, right? Because how does a service provider make money? Well, they charge, and if their platform is too expensive in the back end, it doesn't really work out for them. And then, of course, containers, microservices, things like that. A lot of momentum with ScaleIO. You know, we're very impressed with the numbers. We have rapid growth within our environment, within our industry, within our company. And we're seeing, you know, rapidly approaching an exabyte of storage deployed, rapidly approaching 500 plus customers. And customers are actually realizing actual results. Customers are achieving up to 50% 5-year TCO with ScaleIO. So they're actually saving money on the CapEx side from their infrastructure perspective, as well as the OpEx side from their IT operating model. I won't go over the use cases here, but it's really important to understand that. So if you want a platform that has distributed parallelism, that mesh mirror, with massive performance and scalability, as well as flexibility. If you want a platform that gives you 6 nines availability in a software-defined package. If you want a system in an ESX environment where you can actually share storage across your ESX clusters and eliminate some of the silos that can happen there. If you want a system that can run not only virtual workloads, but also physical workloads, bare metal, OS, Windows, Linux, etc. And if you want a platform that actually can enable you to scale CPU, compute, and storage together or independently, and ScaleIO is going to do that for you. And those are really our 5 superpowers. So I mentioned our next release coming up by the end of the year. We're going to introduce compression, which is important. We're going to introduce vVols, a few other things as well. And if you'd like to learn more, plenty of stuff on our website. So DellEMC.com/ScaleIO. If you're interested in that vExtract Flex consumption model, DellEMC.com/vExtract Flex. So with that, appreciate the time. I'll take questions to the side if you have any, but appreciate you. Thank you for coming to the vBrownBag on ScaleIO for VMware.